Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems section. And if you scroll down in the search question, search the minimum window substring and hit enter. You will find the problem number 76, minimum window substring, and it's come under the hard category, right? So it is mentioned it is a hard category. Yes, it is hard, but if we go with the brute force approach or little bit like some other approach, then we can say like it's not a hard problem. It's a, you can say, easy. Brute force is very easy. A little bit optimization is medium, and very optimization in which we want all the test cases should be accepted, then we can consider it's a little bit hard. But let's try to try to solve this question. Minimum window substring. So what is mentioned? Given two strings s and t. So we have two strings given s and t of length m and n. So there is some length given respectively. Return the minimum window substring of s such that every character of t is included in the window. If there is no such substring, return the empty string. So it is mentioned we need to find some window return the minimum window substring of s. So we need to find some window from this string s string such that every character in t includes in that window. All right. So let's put t contains abc. So if I consider the whole string, so this string contains a b c as well. So I can say okay, my this whole string is the answer. But this is not a minimum string. This is called a maximum string, right? We need to find the minimum window. So what could be the minimum window? So either like if we consider like what is the minimum window in which A, B, C occur. So so till this point, A, B, C comes. So A also come, B comes, C comes. So this we can consider as a one window, but this length 6. And other is we can say like yeah, this as well and this as well, but this contains 2b, which is perfectly fine because it contains all the letter, but it is even more than that. One is this one. This is like again 6 letters, although it contains abc. One is b, a, and c. All right, because b and c also contains abc or letter of t, and and the length is 4. So if we consider all the like possibilities, so b and c is the shortest one, and that's what we want to find. That is the minimum window substring. Uh, that substring which contains all the letter. If there is no substring, so as an example, S is A, T is double A. So we need to find whether all the characters of T within the S or not. So first A is there, but where is the second A? Second A is not there. We can't say like we need both the characters should be in this. So second is not there in the S. So we are returning the empty string. So similarly, as an example, this string S contains A, T contains. We need to find that string, that minimum window substring in which all the letter of T comes. So let's start from the first. So A comes. So that is the minimum window. So that is the like a question. We need to find the minimum window substring. So how to solve this? So first let's try the brute force approach. Don't think even about the optimization. All right. So the brute force approach is like we can check each and every possibility. Right. As an example, if I told you, so this is the brute force approach. We will check all the combination. So this is the like a very large string. So let's like whenever we find some solution, so always work on the some minimum string like to create a pseudocode. So I have to S is equal to A B C D E and C is equal to C E. So C E come in C D E. So C D is the my minimum window substring which contains C and D, and that is the answer. But how I am going to check like which one is the like minimum? So what I can do is as part of the brute force approach, I can check each and every possible solution. So A is one substring, AB is one another substring, ABC is another substring, ABCD is another one string, ABCD is another one string. All right. So first I will check A. So is all letter of CE comes under A? No. Then AB is all letter of CE. All letter of T comes under AB? No. Then CE. Is all letter of comes under ABC? No. Then ABCD. All letter of T comes in ABCD? No. Then ABCDE. Is all letter of T come under ABCD? Yes, all letter come. So one solution is ABCDE, and I can find the length. Length is equal to 5. So one solution is this. Okay. Then I will find the next loop. So B C B D B E. So I can find another solution B C D E. So I will compare the earlier solution with this solution. Which one is the shortest? So shortest is this. So so I will store, I will remove this, and from the result variable, and I am going to store this into my result variable by comparing the length. Then I'm comparing the CD and CDE. Then this is also like coming CDE, like all the characters of T come in the CDE. So this is also the solution. Then I'm comparing with the earlier solution, which is BCDE. Which one is shortest? CD is shortest. So CD is my answer. Then DDE. So not all the characters come. Then E, not all the characters come. So final solution is CDE. Right. So this is the brute force approach. So how we are going to generate all these combination? Right, because to check each and every possibility we have to generate the combination. So how we are going to generate the combination? We are taking AB, ABC, ABD, BE, AE. Then the pointer come here. So basically there are two loops running. By using the two loops we can generate each and every possibility. Right. Okay. And so let's try the brute force approach. All right. So what we are doing is, for I in range 0 to n. And what is n? N is the length of S. All right. N is the length of S. And for j in range I to n and pass. I means 0, because first I is 0. Then AB, then ABC, ABD, like AB, AB, ABC, ABD, ABCD, ABCDE. Then pointer come here. So first I from 0 to n. I is 0. J is 0 to n. So it will take all the 0 to n with the I. Then I become 1. Then 1 from 1 to n, because we can't take 1 from 0 to n, because when I is 1, we have to start from BC, BDE, because we can't do from BA, because BA are already done in here. So we have to start from here only, BC, BDE. So that is from the I position itself. So that's why we took I here. All right. Okay. So we took we run two loops to find all the substrings. So what is the like our window? Window is S of I till j plus 1, because we know if we took I from I to j, then the last element is not included, but we need the last element, so that's why we included j plus 1. So in the window we are getting all the windows in all loops. So we get in the window variable, we are getting A, we are getting AB, we are getting ABC, we are getting ABCD, we are getting ABCD. So similarly we are getting everything. But we have to check, as soon as one window generated, we have to check, we have to compare with the T, whether all the variables are there or not. So how we are going to check whether all the variables of T is in this window or not, whether all the variables of T is in this window or not. All right. So to check that, what we can do is we can create a hash map. So hash map of T, CE, and hash map of let's suppose A. So if we create hash map of A, then it will be like A of 1, and hash map of T is C is 1 and E is 1. And we want all the letters of T should become into A. So we will loop from T whether C is in A or not. No, it's not there. So we will move forward. All right. So that's the same thing we have to check. If C is in A, then we have to check whether the number of key is equal to or not. If the number of key is not equal, or even more, let's suppose if we 2 here, then it is still also fine, because we want more elements are there, but it should not be less. Then it is still fine. So what we have to do is, we created the window. Then we have to check whether that window is valid or not. What does it mean by valid? Valid means whether it contains all the character from the T or not. So how to check? So let's create one more function. Either you create one more function or not, it's up to you, or either you don't want to create, it's up to us. If you don't create the function, then we can like start writing the code here itself, or you can like write one more function as well. All right. So what we can do, we can check we can check flag is valid substring. This window is it valid substring, or we can, instead of window, we can mention substring. Right. So is it the valid substring? We have to check. If it is a valid substring, that's what, if this is the valid substring, what does it mean valid? Valid means it should contain all the letter. If it is valid, then we are going to store the result in some variable. Right. And as soon as we find the another result, then we are going to compare with the previous result, like which one is the shortest. Whatever the shortest, then that is the result. All right. So then we have to check is valid substring. So we are in the class, so we have to do the self dot. All right. So let's create one more function. Def is valid substring. All right. So we have to check whether that substring is valid or not. So we have to pass that substring. We have to pass that substring. So we are passing that substring. All right. And with which we are going to compare? We are going to compare with this hash map. So let's create the hash map. So you can normally create the dictionary by running a for loop, or you can use the counter class from the collection modules. From collections, import counter. All right. So I can create the, because this hash map will remain same. All right. It is not going to change. So that's why I am like creating only at once. Hash map of t is equal to counter of t. So it is going to give me this dictionary, c is equal to 1, e is equal to 1. And I am going to pass the hash map as well. Hash map of t. Okay. So now let's implement this function, whether it's valid or not. So how we are going to check whether, because we find one substring, now we have to check whether CE contains all the letters or not. How we are going to check? We have to create the hash map of substring as well, counter of substring. So one hash map is there and one hash map already there. So we have to accept this as well. All right. So we are checking like this. Now we will check for key in hash map dot t dot keys, because we want all the keys should be in that substring. So for key in, if key in if key in hash map of, or we can directly do like rather than if we can directly check hash map if it exists or doesn't exist, like it's up to us. Hash map of substring dot get key, so that we like just like save some line of code. All right. If key exists, then it will, if key doesn't exist, then it is going to return 0. But if key exists, whether the value is greater than or equal to t dot get of key. Okay. If it is there, then return. If it is less than, then return false. All right. Otherwise, return true. Right. So we are checking the whether the string is valid. So how you are going? So let's put this is a string. This is the string. So we are going to create a hash map. So how we are going to create a hash map? A1, B1, C1, and D1, and E1. And if like it's double A, then A2. then we have to check whether all the element of CE comes into this or not. So we will create a hash map of this. Then we will check whether C is there or not. Yes, C is there, but whether the number of element which is being expected is there or not. So let's suppose here it's 2. Then 1 is expected, 1 is there. But if it is 0, then it is not there. So the same thing which we did, we create the hash map of substring. Substring means we create the hash map of this, all these windows. All right. Then we are looping, because we have to check these keys, because we have to check whether all these elements exist in the substring or not. So that's why we are looping from here. So we are looping. So for key in hashmap dot t keys. So then we are checking if hashmap string dot get. Then we are checking get whether the key has value is less than, if within the substring is value is less, then it means it doesn't contain all the variables. Then we are going to return false, otherwise we are going to return true. All right. So let's suppose if it is valid, if flag, if it is valid, all right. If it is valid, so let's suppose in this case, if it is valid, then we will do something. All right. If it is not valid, then we will do something. Even like if it is not valid, we are not going to do anything, because we have to just like check the another substring. If it is valid, we have to store somewhere. So let's we have to store somewhere. So let's put, uh, we have to find the minimum substring. So in starting, we are taking it's empty, because if we did not find anything, we are going to return empty. All right. And we are taking minimum length as well. Minimum length is equal to, we will take it is as infinity. All right. Then we're checking if flag, if it is valid, if the string is valid, and length of our substring, our the valid substring, because we want the minimum, is less than the current minimum length. If it is there, then the minimum length is, then we are going to update the minimum length, because now the minimum length is this length, length of substring. And minimum string is, because earlier minimum string is empty, now minimum string is this, minimum string is substring. All right. And when all the loops will be done, then we are going to return the minimum substring. So it looks to me like okay, but let's try to run that. So let's run it. Some error expected this. Okay, let's try to run it. So our answer is wrong. So why the answer is wrong? So something is something maybe we missed. We are always getting the empty. So we are always getting the empty. So we miss something here. So we are running to loop from I to j to n. From j to this, we are getting the substring. So we get the substring from I to j plus 1. All right. Then substring. Then we are checking that valid substring, and how to check if substring has less keys than is being expected, then we return false. Otherwise, we are going to return true. If flag, all right, if flag, if it is true and length of substring is less than the minimum length, because we want less than the minimum length, then the minimum length is the length of substring, and the minimum substring is the substring. And okay, so minimum substring. Here I have like used the wrong variable. So let's try to run it. So now all the cases are accepted. So let's try to submit it. So, but this is the brute force approach. Not sure whether the lead code going to accept or not. So it is taking time. So 232 test cases accepted out of 267. So approximately 35 test cases did not accepted, because when the string is very large, then it is not going to accept it because it is taking huge time, right? So, but our solution is corrected because 232 test cases, which is not like a very less number, it is a huge number. So 232 test cases has been accepted, right? So which is our solution is perfectly fine. So that is the, if we consider this, then we can't say that it's come under the hard category. It's very easy category, because we are doing the brute force approach. It's part of the brute force approach. We are checking each and every possibility. How we are checking each and every possibility? By just running the like counters, right? But how we are going to optimize? So even if you watch my earlier videos, I have mentioned, right, time limit is exceeding. And why the time limit is exceeding? Maybe because of these two loops and again one for loop here. So basically three for loops. So so the time limit is exceeding. So we have to reduce the time. So to reduce the time, either we can use the two pointer approach, because here also we are using the two pointer I and j. There are two pointers, but here we are checking each and every possibility. So we can use the two pointer approach. So this solution is correct, but this is not being accepted right now. So let me delete this, because this is anyhow is not going to accepted by the Leetcode. So pass. So let me delete this. Okay, so let's try the another solution. So this solution, like brute force, we have already watched, but this is only 232 test cases accepted. So 35 test cases still not accepted. So let's try to optimize it. So we will use the two pointer approach. So what is the two pointer approach? Everything is going to remain same. Just we will use the two pointer. An example. So this is the string A B C D E. Now we need to check CE. So we will put our both the pointer on left and right. All right. So so our current string is, so because we are checking the current string, so our current string is A, right? Then we will check whether this string is valid or not. If it is valid, then we are going to store in our answer, right? So A, whether A, so right, current string is S of left comma right, dot right plus one, everything will remain same. So current string is this, whether this string current window is valid or not. So it is not valid. So if it is not valid, then we are going to increase our right pointer. All right, so we are going to increase our right pointer. Then we are checking AB. So is it valid? Is it current window is valid? Whether it contains all the letters? No. Then we are going to again increase our right pointer. So now again we check ABC. Whether ABC is valid? No, it is not valid. Again we are going to increase our right pointer. Now ABCD. Then we check whether ABCD is valid. No. Again we are going to increase our right pointer. So R is here. Then ABCDE. Whether ABCD is valid? Yes, ABCD is valid because it contains C and E. So one solution is ABCDE. But we want minimum minimum window substance. So we are now, if we found the valid window, then we are going to starting the compressing. So if we have to compress it, if we have to compress this string, then we have to move the left pointer. So as soon as we found the valid string, we will move the left pointer. So we are moving the left pointer. So we will move the left pointer to here. So BCD, is it still valid? Yes, is it still valid? So so our solution is BCDE. So is it less than the earlier solution? Yes, is the less than the earlier solution. Less than means the in the length only. So BCD is the current answer. Then again we will compress it because still it is valid. If it is valid, then we will compress it. Still we compress it. So how to compress? Just move the left pointer. Then left pointer is CDE. So is it still valid? Yes, is it still valid? Is it still valid? CD is still valid. Then our solution is CDE because CD is less than that the length of the BCDE. Then again we are going to point the DE on the left pointer. DE. DE is valid? No, DE is not valid. So if DE is not valid, so now we are pointing the right pointer. So right pointer, we will increase the right pointer, and the right pointer like move out of the array. So we are going to stop it. So everything is going to remain same, just we are using the two pointer approach. So let's try to use the two pointer approach, whether using the two pointer approach our solution is going to accept it or not, or whether it is still not going to be accepted, or whether right now using the brute force approach only 232 test cases accepted. So is it more test cases accepted or not? So we will like see everything. So we have to take the two pointer left. right? And both are on the starting position, 0 position. And we will take the n is equal to, and then we have to run a loop. So while left is less than equal to right, and right is less than equal to n, and is equal to length of s, because if it exceed the array, then we have to stop. Okay, so we have to get the substring. What is the current substring? So current substring is s of left colon right plus 1. So current substring is this. All right. Then we are going to check whether the current substring is valid or not. So we are going to flags. Everything will going to remain same. Just like instead of two for loops, we are using the two pointers. So if is substring valid, self dot, and we will define this function somewhere. Def and self pass. So we have to define whether this substring is valid or not. So this substring and this substring and hash map of t, because how we are going to check whether the string is valid or not, by comparing with the hash map of t, hash map of t, hash map of t. All right, and yeah, that is perfectly fine. Now we are going to check. So we will create the hash map of substring. So counter of substring. So now we are going to, for k in, then we are going to check the all the keys of t exist or not. Okay, if hash map of substring dot get key, or you can also, or k comma 0 is less than hash map of t dot get k. If it is less than, then we are going to return false. Otherwise, we are going to return true. Right? So if it is valid, if flag. All right. So if flag, then what we have to do? Let's suppose if not valid, because like in our question, what we see, if it is not valid, then we are going to increase the right pointer. So if not flag, what we have to do? We are going to increase our right pointer. Right is equal to right plus 1. All right. So if not flag, so if false, if it is not valid, then we are going to increase the right pointer. Else, if it is valid, we know if it is valid, then first we have to store it, and we are going to increase the left pointer. So anyhow, we are going to increase our left pointer, because if it is valid, we found some valid string. As an example, here we found the ABCD is the valid string. Now we are compressing it, so we have to compress it. That is, we will increase the left pointer. So left is good, but first we have to check like if. So we will take the minimum length is equal to float of infinity, or you can do like you can use the six import sys dot max size, anything like, and minimum substring is equal to this, right? So if length of substring is less than the minimum length, then we are going to update the minimum length. Minimum length is length of substring. All right, because if we found some solution, then we are going to update, and the minimum substring is substring, right? And we are going to, if length is this, and we are going to increase our left pointer. Anyhow, we are going to increase our left pointer. So if not flag, so if flag means if the string is valid. So if the string is valid, we have to increase the left pointer. So that's it. And then we are going to return the minimum substring. So let's try to run it. So time limit exceed. So looks we did something wrong. So let's see. So we are taking the two pointers and length is equal to length of s. We are taking the counter minimum length, minimum substring, which is fine. We are checking, we will run a loop from left is less than equal to right and right is less than equal to less than n. Fine. Then we will check the substring s left right plus one. Then we will check whether that substring is valid or not. So we are checking, okay, hash map of substring. Okay, we are taking the substring of counter. Then we are checking the keys, whether the key is less. Then we are returning false, which is perfectly fine. All right. And if it is not valid, if it is not valid, so if not flag, then we are just increase our right count, right pointer, right is equal to right plus one, and we are again going to check. Right. Otherwise, well, like we have to check if length of current substring is less than the minimum substring. If it is valid, so valid means this string is valid. Then we are checking if length of substring is less than the minimum length. So if it's less than the minimum length, we are going to update the minimum length, and then we are going to update the minimum substring. So minimum substring is equal to substring, and we are going to increase our left pointer. Left is equal to left plus one, and then we are going to increase our left pointer. Left is equal to left plus one, and again it is going to run. So which is perfectly fine, and then we are going to return the minimum substring. Why the time is like exceeded? So let me check. Give me a few minutes. I think this is the wrong because left is equal to because if the length is not less, because we found the valid, but that is not a minimum. But still we have to increase our left pointer. So let's try to run it. Everything, now it is fine. So let's try to submit it. In the brute force approach, only 232 test cases accepted. So let's now we optimize using the two pointer approach. So let's see whether it is going to accept or not. So it is still not accepted, right? So now it is still better than the earlier because now 265 test cases accepted instead of 267. Just only two test cases failed. All right. So this solution is much more better than the brute force approach. But still, this is not accepted by our Leetcode. So how you are more optimize it? All right. Because we know the two for loops, which is perfectly fine. We did that. And we know if we got the time limit exceed, we have to use the two pointer approach. We are using the two pointer approach and still not going to accept it. Then what is the third approach? All right. So there is no third approach. We have to use a two pointer approach only, but we have to little bit optimize this solution to get that accepted. So how to, because like what is the thing which we are repeating? So if you noticed here, let me show you the code. If you noticed here, when we are on the, so when our string is a, when our string is a, we are checking with the, we are checking with the t. When our string is ab, when our string is ab, again we are calculating the hash, we are creating the hash map of ab. But ideally we should not create the hash map again. Only and only we can add this variable, the next variable, into the our hash map. But in our cases, as soon as we found the substring, always we are creating the hash map. Always we are creating the hash map. All right, we are creating the hash map. So which looks like unnecessary repeated, because if we like if we are like as an example, if we are here ABC, we already created the hash map and we know this is not a valid substring. We already created the hash map. Then we increase our pointer to D, right? Now we again have to create it. Then why we are again creating the hash map from ABC to D? Why can't we just update our existing hash map ABC? If we have to update, we have to just add our the new pointer. If the new pointer is, then we have to increase the count, or we have to add the pointer instead of going again from ABC to D and then again creating the hash map. So this looks like a repeated thing to me. All right. So that thing we have to remove. All right. So how we are going to remove? So we have to create one more dictionary in which we are going to store all the variables. Like as soon as we are like moving to the right, we are like storing it. So a we are going to store, B we are going to store, C we are going to store, and as soon as we move left, we are going to delete that, or you can say decrease the counter. Instead of deleting, we are decrease the count, right? But how we are going to, because if we are like let's suppose if we are decreasing the counter, then how we are going to check whether the string is valid or not? So let's try to like implement that. So like we have seen using the two pointer approach, our on, almost all the test cases passed, but except two. And so we have to optimize further. So and we have also like seen, like whenever like we are as part in the two pointer approach, we are taking the substring, and like let's suppose we are taking some substring, and every time like we are like creating the hash map, because let's suppose we already took this substring and now we have to take ABCD. So when we know we already took the ABCD substring and we created the hash map, why can't we just update the dictionary with D here instead of creating like every time the new hash map? So and we will try to like overcome that duplicacy, and we'll see if now the code will work or not. The so so here is the approach, so in which all the test cases should work. We still know whether it's going to work or not, but the approach will remain same. We will take the two pointer, both the pointer will be on the starting. So we will take the two pointer, both the pointer will be on the starting, right? And we will keep moving our right pointer like until the some valid string found, and as soon as, so we will keep our moving right pointer until the valid string found. As soon as the valid string found, then we will move the left pointer, right? Then we will only move the left pointer. But this time instead of like okay, we are keeping, but how we are checking, like let's suppose let's suppose we have our pointer here, our both pointer here, left and right here on this window. So window is A. So instead of just creating the hash map for A, so we will create the hash map of A generally, like in the earlier case scenario. And when we move to the pointer B, then we are creating the hash map for A and B. So instead of creating the hash map again for A and B, we will just add the B in the existing hash map. So it means we have to take a common like dictionary. All right. So length is equal to S, and the minimum length is equal to, everything is going to remain same, just a little bit like a modification. So minimum, and the minimum string will be this, and hash map for the T will be counter of T. So do we need this or not? Hash map of T. Okay, we'll see. And then we will create some hash map. So temp hash map, in which we are going to store the all the variables. So we will run a loop, and when till what point we have to run a loop, because when the right pointer will exceed the till reaches this endpoint, and we know as soon as we found, like we have to store each and every variable in our like some dictionary. So we are moving. So we are going to store in our temp hash map. So temp hash map s of right. is equal to temp hash map dot get s of right plus 1. So basically we are creating a dictionary. So there we will create a temp dictionary. So right now our pointer is on n or r. So we will create a dictionary. So a is 1. All right. So then our pointer, then we will going to check, because as soon as this is our first window, and in our early case, when we find out the first window, we are going to compare our first window with the we are comparing whether all the elements in the C are there in the in this particular window or not. All right. So if it is there, then if it is not there, then we are increasing our right pointer. So same thing, but instead of like so up one window is there, right? So how we are checking like whether the existing window is there or not. So we are checking. So if hash map, so if so we have to check. We have to check if s of right in hash map of t, if that is in there, t of okay, in this if so we are checking like because whenever we found like what we are doing earlier, as soon as we are finding the one window, we are first checking whether that window is valid or not. And how we are checking that window is valid or not? Like in early approach, we are creating some different counter of that substring, but in this, because that is again the duplicacy, so we are not creating. So we are creating the like normal one common hash map. So we are checking if s of right in the hash map, if that keyword is there, so it means we found at least one element. All right. Then also, so if it is there, and then we are going to check if temp hash map of s of right is less than equal to hash map of t s of right, then we are going to increase some count, and we will take the count variable is equal to 0. So let me explain you what we are doing is, so there are two ways to check whether our like all the elements of T exist in the particular window or not. All right. One way is that we will create a hash map every time. So first window is this A. We are creating a hash map. The next window is AB. Then we are creating a hash map. The next window is C. We are again creating the hash map, and again we are checking. The next window ABCD. So we are again creating a hash map, and again we are checking. But there is a one more approach, because we know we already created a window for A, and then we are just adding B. Then we are just only adding C in the existing window. Then we are adding D in the existing window. So what we can do is we will correspondingly check. As soon as we added A, we will check whether A is in the here or not. If it is A is not here, then we are checking B. If B is not here, okay, then we are checking C. If C is here, if C is here, we are counting our, we will take some variable count, and we are increasing the variable count plus 1. So right now count is equal to 1. So it means we found the one value. Then we are pointing it here, then we are pointing it here, then the count is 2. So count is 2. If the count is equal to the length of t, it means we found the valid substring. So instead of creating two hash map and every time running one more loop, we can just like, because we are checking just using the if condition instead of running for loop condition every time, we are checking if the count is equal to 2. And whenever we move our left pointer, then we will decrease the value from here, and we also decrease the count as well. So this thing we have to do. So that's the same thing like I write it in the code. So we in starting we point, like we are still using the two pointer approach. We are pointing left and right to the 0. All right. And we know we have to go till end. Okay, we have to go till end. As soon as we found the first element, we are storing in the dictionary find. Okay, then we are checking whether the element in the hash map or not. Yes, it is in the hash map. Then we are checking because whether if it is in the hash map, because we are creating the dictionary and we like the value could be 0. Then we are checking if the value is less than that, then we found the then we are increasing the counter. All right. Okay. So we are increasing the counter and we will do the right is equal to right plus 1. So again it is going to check, again is going to check, but at what place like we are going to know whether the string is valid. So as soon as we find the count is equal to count plus 1, now we have to check whether the string is valid or not. And how we are checking the string is valid or not? So we have to again run a while loop while left is less than equal to right, and count is equal to length of t. So if count, this count is equal to the length of t, then we are getting some valid substring. And if we are getting some valid substring, we will check if minimum length is greater than right minus left plus 1, because our right pointer is at some place. So here, so let's suppose let's take this example. So right initial left and right on this is this place. So sorry, left and right on the 0 0. Then we are we have to move the only right pointer. Then we just add into some temporary array. So temp hash map. So this is the temp hash map. This is the temp hash map. Okay, we are adding a is equal to 1. Then we will check because first window is a. Then we have to check whether a is in the hash map of t. A is in the hash, and t, we also create the hash map of t. We also create the hash map of t, comma 1, and which we are already creating like in every approach. Then we are checking whether a is in there or not. So a is not in there. Then we are going to increase our right pointer. All right. So that is fine. Then we are checking b. If b is there, no b is. So we are first we are adding b. So we are adding. So b is in the hash map. No. And then we are adding the c. So c in the hash map. So c is in the hash map. So whether this value is less than equal to this value, yes, is less than equal to this value. So we have to increase the count. So we found one variable. So count is equal to count 0 plus 1 is equal to 1. We found, so initial value of count is 0. We found one variable. All right. Then we are like we found one variable, and at every place we have to check whether the count is equal to the length of this element or not. If the length of this element, then we have to increase our left pointer, right? And we have to, so let's suppose the right is now here, the right is now here, and right is now here, and then the right is now here, because c is equal to 1 and the count is still 1. And then the d is here, and then e is here, right? So count will be become 2 because we found the two elements, and which is equal to our the length of the t. So now we found the length of the t. So we have to store this thing. So what is the minimum length? R minus L. That is the total distance. R minus L plus 1. So that is I minimum length is, if minimum length is infinity. If infinity is greater than right minus left plus 1, then we have to update the minimum length, which we already updating. So right minus left plus 1. And we have to update the minimum string. Minimum string is s of right, s of left, s of left till right plus 1. Then the minimum string is, so first we found this string. So one string has been found. All right. But as soon as we found the one string, we know we have to move the left pointer. All right. We have to move the left pointer. But how we are checking? We found the string by using the count variable. If the count is equal to the length of t, so that's the same thing we are doing. If the when like while left is less than equal to right, and if the count is equal to length of t, we are doing this, and we are increasing our left pointer. Along with that, if we are increasing our left pointer, right? If we are increasing our left pointer, then we have to decrease the value of a from here. So now a will be 0 here. All right. So we have to decrease the value of a from this from here, from hash map. All right. And also if a exists in CE, because count variable is 2. 2 means only those elements which we found from T. If the count is, if A in the CE, then we have to decrease the count variable as well. All right. So the same thing we have to do. So if so first we have to decrease the we have to decrease the count of this, because we have to move our left pointer, we have to decrease the count of this. So uh, even before increasing the left pointer, we have to decrease the count of this. So temp hash map as of left, we have to decrease the for the left. Temp hash map dot get as of left -1. So because we are proceeding further, so we can make it 0, because now the substring will be this. If the substring is this, so instead of recreating the hash map, we are just updating it. So it is 0, right? But count is 2. So we also have to check if s of left in hash map of t, if it is there, if if this element is in there, it means that is the part of the count as well, because we are increasing the count. Then we have to, like, there is one more condition, and if temp hash map s of left, we are checking the key. If the key is less than equal to hash map of temp, then we are decreasing the counter as variable count -1, and we are increasing the left pointer. So we are still using the left and right pointer approach, but the way of checking, and we are still doing the same thing, right? We are increasing the right pointer, and as soon as we found the valid window, we are like increasing the left pointer. The same thing we are doing, but the way of checking, earlier what we are doing is we are every time creating a hash map, and then we are checking this hash map with this hash map, whether all the elements are there or not. So instead of that, we do just one variable, and we created only one hash map, and we taking one variable. As soon as we found the element, we are increasing our count. All right. And as soon as we are removing, we are decreasing the count. We are increasing the count, and we are checking if the count is equal to CE, it means we found the one valid string. So that looks like okay to me. Let's try to run this. So it looks okay. Let's try to submit it, just to check whether all the test case has been accepted or not. So now we could see our all the test case has been accepted. So earlier our all the test cases is accepted except to using the two pointer approach, but still we are using the two pointer approach. So let me show you. So earlier what we did is we use the brute force method. All right. So in the brute force method, we run the two loops. So when we run the two loops, so only 231 test cases pass or 232 test cases pass. Okay. Then we use the like a two pointer approach. When we use the two pointer approach, then 265 test cases pass, but still two are failing. But in this case, what we are doing is every time, because we are running one while loop here, which is fine, but one for loop is here as well, because every time we are creating a substring, we are creating a hash map of substring, because there is every time there is a new substring, and every time we are creating a new hash map. So instead of updating, and every time we, by running the for loop, we are comparing it. So we have just like, we have to think in such a way, can we remove this part, can we remove this logic. So to, because every time we are creating a substring, so instead of every time we are creating a new substring, because we know we are increasing and decreasing only one element, so can't we just update that element? So the same thing which we did only. So we created some dictionary, and as soon as we find the first element, we are just updating the dictionary. We are updating the dictionary, and instead of checking using the for loop, instead of checking using the for loop, right, we are increasing our count. Count is equal to count plus one, and everything will remain same. The way of checking is same because here we are also checking the same thing. The returning is same. Increasing the left counter is same. Increasing the right counter is same. Just this part will like is going to check. Otherwise, while loop is same, while right is less than is equal to same, everything is going to remain same. So now our solution has been accepted. So if we are doing using brute force, then it's easy. If we are using two pointer approach, that is we can say okay, if someone doesn't do two pointer approach, then for that person it could be medium. But to think in this way, right, then it will be like, that's why it's come under the hard category. That's why like it's hard because using the two pointer approach, only two test cases are failing, but lead code wants all the test cases should pass. So we have to think in such a way like a little bit approach. So this approach, like can we use only one hash map and just increasing and decreasing the element and just the count, we checking the count and then checking the count is equal to length of t. So if we do this way, then our all the test case has been accepted. So that's it. You can also try this question. So if you don't understand this logic, I think that is still fine if you understand the brute force and the two pointer approach. Because if you understand the two pointer approach, now as soon as you understand the two pointer approach, that is the second approach which we run, in which 265 test cases run. As soon as you understand that approach, now that is perfectly fine because if you clearly see that approach, now you will automatically guess that we are unnecessarily uh, we are unnecessarily creating a dictionary again and again and again, because I already created the dictionary till D. If the E element is there, I am recreating the dictionary from A to E instead of just updating E in the existing dictionary. Right? So to overcome that scenario, we come with this solution. If you find uh, some other solution, like the logic will be remain same, but and we will use one dictionary and we are going to play with that, then that is the very best solution. So that's it at the end of the video, and thank you.